Good afternoon. Thank you for joining today's webinar featuring PCL Construction. Today's session will cover utilizing Revit Parts and PCL PartsLab in Assemble. It is my pleasure to introduce you to today's speaker, Tim Kelly, Product Manager at Assemble. Go ahead, Tim.
Thanks, Samira. So today I'll kick it off with our agenda. We're going to cover introductions, myself and our guests today, and talk about our organizations just briefly. And then we're going to dig into what Revit Parts are and how PCL's created their own tool that they're sharing with the industry to manage those parts. Right on from there, we're going to dive into how Assemble now manages and leverages the use of parts for different workflows in your Assemble process, and then dive right into Q&A. So with that said, a little bit about me. I am from Texas A&M in construction management degree. I worked in the industry for a number of years prior to joining Assemble as a product manager. And my time in the industry, I spent quite a bit of doing model-based estimating and VDC management. So both in pre-construction and in construction. And ultimately, back when I was doing this, we didn't have access to this parts information and the tool that PCL has created, PartsLab. And I'm really excited to share this with everyone today. And with that, I'll go ahead and introduce our guest speakers today, Nick, Kurth, and Daron Denton from PCL Construction. Nick, why don't you go ahead and introduce yourself?
Yeah, my name is Nick Kurth. I'm manager of virtual construction for PCL's U.S. operations, headquartered in Denver.
And this is Daron Denton. I work directly for Nick Kurth at our U.S. headquarters in Denver. I'm the manager of virtual construction research and development.
A brief overview for those on the line that aren't familiar with Assemble. Ultimately, we're a cloud-based environment to publish your information from different design applications into our environment, which will allow you to manage, organize that data, use that data to leverage the information out of the model, and ultimately share it across your team. So in a sense, we're connecting the design, construction, and operations spaces with the 3D models and the metadata within. Ultimately, we allow you to leverage data out of Revit, AutoCAD, CADWorks, and other systems for your use in planning, estimating, design review, etc. Our tool is totally on the web, so there's very little training and very light process to get started. There's no install. It's totally web-based in that environment. So that's a little bit about Assemble. Nick, why don't you talk a little bit about PCL?
To give you a little idea of who we are at PCL, we're a general contractor with offices across North America and Australia. I won't bore you with all of the details and all of our statistics, but it's good to note that we work in 3 primary markets: heavy industrial, civil infrastructure, and commercial buildings. So before we get into the details, I wanted to share with everybody sort of our strategy and tool sets that we use that surround Revit Parts and why we develop PCL PartsLab. Essentially, our goal is to democratize the use of VDC across our operation. We want everybody in our pre-construction departments to our operations group to have the ability to leverage these models and the data within the models. We want to work hand in hand with our designers to leverage their models rather than build our own models. And ultimately, that leads us to become model managers, not model creators. You know, we are able to leverage data sets that already exist, like I said, rather than creating our own. And this really eliminates the need to recreate a model and gives us the ability to use that model for planning and project management. And we can put our fingerprints all over this model, use it for construction purposes without compromising the integrity of the model, and at the same time continue to consume updates without losing our work. And with that, I'll hand it over to Daron Denton to give you guys a little insight into what we're doing.
Thanks, Nick. So before we dive into parts, I'd like to briefly mention why PCL is using parts. To solve the challenge Nick mentioned of preserving the integrity of the delivered design model data, we set a goal to leverage that geometry that already exists. So how can we add detail on top of what we already get and have that detail survive an update process when that design geometry changes? And so that's when we took a look at parts to try and solve that issue. So parts is a native Autodesk Revit feature that essentially creates a clone from the original object. Parts acts somewhat like a shrink wrap object around the original object. So if the original object moves or changes shape, the parts automatically update with the original object. There's quite a bit of native functionality that allows you to do some pretty complex shape modifications, all without disturbing those original objects. One other note we'd like to make with parts as well is, like all model objects, parts have an object ID, so you really need to be aware of that when you're creating parts, deleting them, and also if the host objects, the original objects, are deleted, you can have some effects there as well. We're going to jump into Revit real quick and just look at some basic behavior with parts. So in these two views that you're looking at, we have the same wall in both views, and we are going to turn one of the views into parts. So we have the wall selected, and from the ribbon menu, we're going to select Create Parts. And so with that click, if we zoom in on the corner of the wall here, you can see the original wall is still maintained, but where the view that's showing the parts, each individual component of the wall is now an individual object. And so we can now start modifying those objects. We'll go into Properties and turn on the Shape panel. And if we grab the grip, we can now start modifying these objects. So you can see, as we've made these changes, the original object over on the other side is not changing. If we modify this original object, it's going to change the height. You can see that all those parts update as we're moving this object. So when we create parts, this allows us to add all the detail, the slab core breaks, block outs, adding sleeves to those original objects. And again, we're not disturbing that original geometry. So now we're going to open up a little bit more of a complex model. Okay. So this model is an aggregated construction model. On the right-hand side, you can see the linked-in geometry. And on the left-hand side, you can see where we've already created parts, and we've started breaking some of those parts up into the pores as we would build it. So you can see the floor parts have been divided into pores, and you can also see the walls have been divided into how we might pour those walls. So aside from making port breaks, we can also make other modifications. If we look at the foundations on the building, you can see that the column footings are a little bit deeper than the wall footings. And so we would typically build that all at the same depth. So we need to normalize the depth of these footings. So without requesting a model update from the structural engineer or having to go in and modify that model directly, we can just grab these parts and again turn on the shape panel. I'll grab the bottom of the footing, and I'm just going to snap it right to the bottom of the column footing. Whoops. And so now you can see the bottom of the foundations on the left where we have the parts. All these are normalized, and we did not touch the underlying linked geometry. So not only is it visually correct, it's going to give us correct volume takeoffs on the concrete. We can dimension it properly. It is actually how we're going to build that model.
And for anybody who's not a Revit expert, just to kind of reiterate what Daron's talking about with linked models, this is how we aggregate multiple design models from a structural engineer, an architect, or multiple architects. We link them into this environment so that as we receive updates from those designers, we're able to consume those design updates very, very easily.
So here's a view with just a little bit more context in the same corner of the building. And what we want to show you here is a few more modifications that we might want to make. So again, this is all native Revit functionality that allows us to do the detailing. So in this project, here's our link content. And you can see that this column has been created in a way that it spans many levels. When we build that building, we might want to pour those columns level by level. So we're able to make modifications to the parts to accurately get those takeoffs. So I'm going to select one of these columns and isolate those columns, select them all.
Daron, as you're doing that, if you guys are noticing, Daron he's in the toolbar that's custom to this PartsLab. So these are created tools that allow you to really quickly jump into specific categories, level by level, that sort of thing. So make sure as you're going into that you guys are paying attention to the fact that he's able to quickly filter and sort using this tool set.
Yes, thank you.
Absolutely, Tim, and we're going to hit those very specific features here in a minute once we go through kind of what the native functionality it offers.
Yeah, definitely. So these columns have been isolated, and now we want to divide them. And this is a native Revit feature. Right up on the ribbon, we'll use the divide tool. And under intersecting references, I'm going to use a building level to slice those columns at the level. So we'll use level, building 1, and select OK. And we hit finish. Now you can see that those columns are actually divided. And again, we did not disturb the original delivered geometry. So if we reset that view, you can now see in context, this is actually how it would be built. There's a few other nice little features in the parts where maybe that building level was not actually located where the top of the column is. Maybe we want the top of the column to be 6 inches below the slab. We'll go back into that division, and under intersecting references, the reference that we used, I'm going to give it an offset of -6 inches and hit finish. And now that column stops at the bottom of the slab, not at the top of the slab. So the features and functionality of parts really allow you to get down to exactly how that's going to be built.
And this is all without having to call your designer or ask them to do anything specific or impose upon them any modeling efforts that they wouldn't typically do.
That's right. And this is huge because when you think about the design process here, they're not thinking about means and methods. You haven't determined exactly how you're going to pour this just yet when they're designing this. And so trying to have that conversation once you guys get the model, that becomes just kind of, okay, we have to go back and do that now. Well, with parts, this is the case that you can do whatever you want. And so you have that ability to really drill in and do it exactly like you plan on actually building it.
Yes, as Nick mentioned before, this allows us to now be detailers, not modeling. We're not creating geometry from scratch. We're actually detailing modeling that already exists. So one last thing we'll show you with parts is the merge feature. And here we have a wall part and a column part, but maybe those are going to be poured as one pour. You can select several parts in Revit, and then using the merge feature up on the ribbon, those objects are now one object. So the original geometry from the linked model is still separate, but this is now one object that would reflect the correct volume of what's happening. And again, if the underlying geometry moves, relocates, changes, those merged parts will update with the underlying geometry. So what is PCL PartsLab? The PartsLab is a free Revit add-in. You can find it at partslab.pcl.com. It's also available at the Autodesk App Store. We've been using it internally for about 4 years. And the three core purposes of PartsLab is to automate the parts creation process from targeted content. The second purpose is to expedite model investigation. So you really don't want to create parts out of everything. You just want to create parts out of the objects that you're either trying to modify or maybe aggregate. And so PartsLab allows you to browse all of your linked models and find that specific content and target it for parts creation. The third purpose are the visualization tools that were mentioned briefly, and we'll show those again. But once you've created all these parts, the visualization tools allow you to quickly work with these parts, isolate, hide, without creating a bunch of new complicated views and filter setups. So this really lends itself again to people that are not Revit specialists. You can really just get in and start using these tools and parts. We'd also like to mention what PartsLab is not. PartsLab does not create proprietary geometry or objects or data inside of your model. So if you do use PartsLab and then for whatever reason you don't have PartsLab anymore, or you're using the model on a computer that does not have PartsLab, everything functions as it did before. Whether PartsLab is there or not doesn't have any impact on the usability of parts. So using PartsLab. So the image at the bottom of the screen shows our typical construction model workflow. And as Nick was talking about before, we really wanted to have a scenario where the design geometry can be continually delivered throughout the construction model process. So on the right-hand side, you see the construction model, and that's where we create all of our parts. We do all of our pour breaks, as you saw, the column modifications, embeds, blockouts, sleeves, anything that we might need for our construction model happens on that right-hand side of the image there. So on the left, you're seeing the design cycle, and the design models are linked into that construction model. So as that design cycle matures and we have to update those linked files, we don't lose all the work that we've done inside of that construction model. And so for using PartsLab, we are going to be opening up another model, and the delivery scenario on this model is there are two models linked in. One is from the structural engineer. It's a concrete model that it includes floor slabs. And the second linked model is from the shell architect. And this model also includes floor slabs. So the shell architect, there was quite a bit of complexity to the curtain wall, and so they were responsible for the slab edges. So because there are slabs in both models, we've got some duplicate geometry. So to prevent those duplicate parts, PartsLab is going to help us target that specific geometry so we can create an aggregated model. So on the left, we have a view with just the linked models. We've got the concrete structural model, and the empty right-hand view is a model that is going to show the parts once they've been created. So let's go ahead and start PartsLab. Okay. So inside of PartsLab, on the top right corner, you can see it's listing all of the linked models. So again, because the shell architect was responsible for the slabs that are going to be touching the curtain wall, we want to create those slabs from the shell architect's model. So let's turn on the shell architect's model. And on the left-hand side of PartsLab, you can see the content from that model. So we could open up the floors, take a look at the content. Okay, there's 3 floors. They're all of the same type. But we also want to target just specific levels. So on the bottom right, you can see all the levels from the building. I'm going to click none, and then I'm going to turn on levels 2, 3, and 4. Those are the targeted levels from the linked shell architect's model that we want to create floors. So we're going to target those floors, and we'll tell PartsLab to create those parts. Okay, so you can see the parts have appeared over on the right-hand side, and it tells us 3 parts were created. So now the rest of the concrete, we want to create that from the concrete structure model. So we'll turn on the concrete structure model and turn off the shell model. And you can see our level list is still filtered for those 3 levels. So since we already have those levels, those floors from the other model, I'm just going to invert that list. Our floors are still selected over on the left-hand side. So now we'll tell PartsLab to create those parts. Okay, so you can see on the right-hand side our concrete model is starting to take shape. We have these individual parts that were created from the 2 different linked models. Now let's create content from the rest of the objects from the structural model. So in the filtering, I'm going to turn all the levels on the right-hand side. I'm going to turn off the floors because I don't want to duplicate those floors. And now we'll turn on structural columns, foundations, and we'll turn on our walls. And let's create those parts. Okay, so we're getting a little message from PartsLab. Some of the parts that it created were from objects that are not associated to a building level. And those in this case would be the foundations. Those are hosted by walls, not by levels, so there won't be an associated level with those objects. And with those few clicks, we created 836 parts. That would take a substantial amount of time doing that manually in Revit. Okay, so now that we have all of these parts, we've got our aggregated concrete model on the right-hand side. And the last thing we want to, or one of the other things we want to show you with PartsLab are the visualization tools. So now that we have all these parts, maybe we want to start working with the basement of the building. I wanted to isolate the foundations and those basement perimeter walls. So I'm going to select one foundation object and one wall. And these are the PCL specific visualization tools that were mentioned before. I'm going to go up to PCL Isolate and hit Isolate by Category. So just with those couple of clicks, without creating any special views, I didn't create any view filters, I was able to isolate just the foundations and the basement walls from that project. If you want to clean it up a little further, I can select one of these interior walls, and instead of isolating, we're going to go to PCL Hide, and we're going to hide by type. So with just a few clicks, you can really set up a view to see just about specifically anything that you want to see with parts. And the last thing that we want to show you, you may have seen when we were creating parts, I didn't mention this before, but you get this little pop-up that's somewhat like a little bit of a revision as you create the parts. This allows you to associate information to the parts that you're creating so that you can go back at a later time and manage parts based on either where they came from or what revision they were a part of. And if we go to the Settings tab in PartsLab, if you click on Show History View, this is going to open up a different view. And using this revision log, simply by clicking on a different revision, you can see highlighted in green which parts were made during which revision. So again, this just really helps you understand 8 months later, 10 months later, when those parts were created and what revision it was a part of.
Absolutely. It's a very nice component for managing models, managing model updates, and just a way to see it very, very quickly. All right. So, Tim, we're going to pass it back to you, but before we do, just to recap what we just went over, you know, it's about managing the model, managing updates from our design team, and then being able to make edits to reflect means and methods for these projects that we're working on without drastically impacting the design team's workflow or their process.
It's about keeping that relationship between what you get out of the design model and not really disturbing in the past, you take a column and you copy and paste it, you paste it by level, break it down, that sort of thing. You don't have to deal with that sort of breakdown anymore, and this tool makes it really easy. As you mentioned, Daron, I think you said you created 836 objects in that just a couple of minute span. That's pretty difficult to do with just a native parts tool without just doing it for everything. And as you mentioned, you really don't want to do it for everything. You want to manage discreetly what you're doing it for. So that's fantastic. So with that said, Assemble is now consuming parts from Revit as a category. And I have on the screen just Daron's model, and as he mentioned in the tool, essentially what they're building out is a construction model from the design model. And when you land in Assemble, I'm going to go ahead and turn off the original design structural model, and you're going to see essentially just the construction model. What you'll notice right off the bat is there's nothing there. I have some structural connections there, but nothing else. What we do by default, so that we're not disrupting those of you not familiar with parts, with implementing parts that you may or may not have created yourself is that by default we're going to ignore them. The reason that we're doing that is that in your inventory and in your model view, you ultimately have duplicate geometry that comes from the part itself and the original category. Ultimately, these are your parts that were created from the parts lab that Daron just walked through. And the idea here is that I have the original type information associated to that. So all of these parts have their own property sets. Just as they do the original components that have properties, we actually carry across the information about the original category, family, and type. And we also, whenever you create a part, have the host ID, as well as on the original component have a tag that says this thing has parts, it has children, right? So that manages the system to the subcomponents. Ultimately, we're doing that same thing now for curtain walls, where you have a curtain wall that has children that are the curtain panels and mullions. So imagine that same relationship. So what you're seeing here is that I have this broken down by the original type, but what if we want to go down deeper to the material level and start to do material type takeoffs? I'm going to switch out of concrete for a minute. I'm going to give a different example with some drywall and breaking up those walls. And really quickly, I have some components here, and I'm just showing all of the model. I've turned parts on, so that's included in my inventory. I want to go ahead and get rid of everything but parts so I can start to drill into my interior partitions takeoff. So I'm going to hide everything else except for my parts. And that's my category, right? So we want to use some other data set to reorganize this and try and drill in. I'm going to go to, so let's specify original category. Right, so then I'm going to go to my walls, and I have my original category as walls. Let's get rid of the ceilings and slabs and other things that we've broken down. Okay, so now I get to the point of saying, okay, I have these different things that were created, and I want to look at the types that are there. I have my A interiors, etc. I have some other things that were maybe grade beams that were created as walls. Again, continuing to drill down further, I'm going to get rid of anything that's not interior. I have these tags of interior A1s, 2s, 3s, etc. So I'm going to hide these. And at this point, I've gotten down to essentially what I see as my interior breakdown of materials. If I now switch this over, I'm going to actually, before I do, I'm going to select one and go into my properties here. And you're going to see my host ID, right? The original information, I have material by information. Now with this component, because I'm not selected on the whole wall, but rather just the drywall, and I can select the stud, etc. That material information actually has the detail about the subcomponents, the layers of this wall. So if I go and I regroup this model by material, ultimately at this point we're now getting down to getting the details of essentially a material takeoff by master format division. So I can look at just my chipboard, right? And I can see across my model where I don't have chipboard, and if I want to go select something, I can figure out that, this is metal furring, so this may be exterior. And I can really start to drill into what those materials are and relate them ultimately back to the original component if I need. So if I get in right into one of these items here, I'm on a stud layer here. Maybe I want to change now, if you think about the takeoffs for different types of materials, total linear feet might make more sense for studs, where gypboard makes sense to use the square feet. Now that I have these parts broken down as subcomponents, within Assemble I can start to associate different quantities to each component and ultimately different cost if I want to get into that type of detail. So now within my inventory I can start to break this information down, where I have my square foot of this item, linear feet of this item, etc. So in addition to being able to break it down by means and methods and for sections and sequences, what you're now getting as well is the ability to break it down by layers, by subcomponents that are within Revit that we're consuming into Assemble as well. So with that said, that pretty well wraps it up. What I want to do is go ahead and thank Nick and Daron both for taking the time to talk about PCL PartsLab, but also for benefiting the industry by creating this tool as an internal tool and saying, you know what, we want to give it away for free, and allowing us out there that are using these models to drive projects forward and do estimating and do schedule management and all the other things, the ability to access and use that for